let's talk about linear versus nonlinear again. If a function's another word for an equation, okay? So you'll elaborate more on that in 8th grade and then more in Algebra 1, but just for now we're going to use that interchangeably with the word equation. So if it's linear, the graph forms a line. Y increases or decreases at a constant rate as x increases or decreases at a constant rate. The independent variable, which is the input, has an exponent of 1. And the reason that we have to specify that is the further you get into math, the exponent will not be 1 every time. Okay? Verbal description includes words such as per, each, and every. All right? Nonlinear, the graph does not form a straight line, and the rate of change is not constant. The exponent of the independent variable is not 1, so it could be 2, 3, 1/2, whatever else, just not 1. The verbal description includes words such as cubed, squared, exponentially. Okay? So you should have been given some different little squares. I think there's 8 of them. All right, and we're going to sort them into either linear or nonlinear. And we're going to glue them down. Linear or nonlinear. So look at number 1. Number 1, is it a straight line? Okay. If it's a straight line, it's going to be linear. So you can glue that into your linear category. Let's look at number 2. We need to figure out if this has a constant rate of change. So I'm increasing by 2, increasing by 2, increasing by 1, increasing by 1. So that's a rate of change of 2 over 1 or 2. So yes, that's linear. Number 3. Is number 3 a straight line? No, this is actually an exponential graph. Okay, and you guys can talk about that later on in algebra. Number 4, looking at your independent variable, which is your x, your independent variable, does it have an exponent of 1? If there's not an exponent there, it's an exponent of 1, so that is linear. Number 5, however, has an exponent on the independent variable of 2, so that's nonlinear. Okay. Number 6 says pays $2 for each song. Each is one of your words that tells you linear. Let's look at number 7. I'm increasing by 3, and then I'm increasing by 5, but it's an increase of 1 over here. So I have 3 over 1 and I have 5 over 1, and those are not equal. So it is not linear. And then the last one says volume is the cube of the length, and so that's a nonlinear term. So you're going to glue those down, and then we'll move on to the right-hand side. Okay, so now that you've glued those down, let's look at the right-hand side. On the right side, we have 6 examples, and we need to know if they are linear or nonlinear. Using what we did on the left-hand side, you need to simply circle yes or no. Are they linear or nonlinear? That should be very easy. Should not take you but a few moments. Okay, and make sure that you clearly mark yes or no. And then down at the bottom, we're going to talk about from a table if it's linear or nonlinear. So remember, on the left-hand side, we found that constant rate of change. And then if it was the same, it was linear. If it was not the same, it was not. So let's try this one. All right, and you can write your constant rate of change down here and say if it's linear or nonlinear. And then let's try one more. Okay, and again, if it has a constant rate of change, write it down on both of these. If it doesn't have a constant rate of change, show your proportion like we did on the previous side, and then tell me if they're linear or nonlinear.